we'll go through this here. Now, we can start off with these first problems here. Let's clear this out. So the first ones we're looking at are 1 through 4. Find the indicated root, nth root of a. So for number 1, we're taking the 4th root of 20,700. Now for this one here, we can just plug it in. 4th root 7,000. That's right. Well, I apparently had all the right numbers, just not in the right order, which is 12. Well, this here is, you'd still lose points for this here because it's not just 12. It is plus or minus 12. Because whenever we take the even root, take an even root of a number, we need the plus or minus. And this is going into the fact that negative 12 to the 4th is 20,736. 12 to the 4th is still 20,736. Both give us the same answer. So it is plus or minus 12. Or if we looked at, say, the 9th root of, we get 2. So we can plug it in. 512 is, all right, that's it, is 2. Now if we do 2 to the 9th, we get 512. If we do negative 2 to the 9th, we get negative 512. They're not the same. So with odd roots, we don't have the plus or minus. With even roots, we do. So with number 3, we would have plus or minus. With number 4, we would just have whatever the number is. Any other questions on these here? For problems 5 through 8, evaluate. 8 to the negative 2/3 is 1/4. We can do the same thing with 1/4 to the negative 5/2. 1/4 to the negative 5/2 is, I mean, we could do the same thing with 16 squared to the negative 4. Parentheses, parentheses, 16 squared to the negative 1/4. I think I technically added an extra parentheses, but that's fine. Enter is, yeah, 1/4. We could do the same thing with 7, and we should get 1/27. So the next 4, evaluate each expression and round to the 4th decimal place. 974,231. $9.95658. So 9.95666. So we rounded the 4th decimal place, so we should have 4 decimal places. And here we get this here. And the rest, 10, 11, 12, we just plug them into the calculator exactly as they are and get our answer. So I wouldn't change anything to them. So like with 12, I would put parentheses, 5th root of 8, close parentheses to the 8. Just type it in as you see it. Any other questions on these here? So, I mean, we could try, so simplify each expression, use the properties of rational exponents. So we could try 13. Parentheses, 6 to the 3rd to the fourth. This gives us a decimal. Now, it doesn't say to round, so this is not the correct answer. You could put it, I would mark it wrong, but because using the properties of rational exponents. Now, powers of powers multiply. So it'd give us 6 to the 3/4. Now, we could plug it back in. So I could grab the calculator again and say 6 to the 3/4, which is this here. Those are the same as what I started with, so 6 to the 3/4. It's a way to check it to see if the decimal answers are the same. So this one here has a negative exponent. Most likely it's not going to simplify, so there's no point in plugging it in. Well, 9/12 will reduce, won't it? To 3. Just like with the last one, we can apply the exponent to both terms. Now, because we don't have an exponent with 3 or 4, we can apply the negative 3/4 to both. Because it's really just multiplying it with 1. 1 times negative 3/4 is negative 3/4. But we can't leave it as a negative exponent, so we've got to move it from the numerator to denominator, or denominator to numerator. Flip it. 4 to the 3/4 over 3 to the 3/4. And that would be it. Questions on any of this here? Well, with 15, we can try plugging it in. Fraction 2 to the 2/3 times 16 to the 2/3 over 4 2/3. And since this gives us a decimal, we can't do it, or wait, whole number. So the answer is, yeah. Because if it works out that it is a whole number, we don't have a non-repeating, non-terminating decimal. That is the answer. Yeah, really, we can pull the 2/3 out. So we get 2 times 16 over 4. Now, well, we could do 2 times 16, which is 32, divided by 4 is 8. 2/3 of 8. Well, the 3 on bottom is the cubed root. We're talking about the cubed root. What times itself 3 times is 8? 2. So we're really looking at 2 squared, which is 4. So we see how we kind of work that through. We could have done it the other way and said 8 squared is 64 and found the cubed root of 64, which is 4. Either way would have worked. Does that make sense? The last one most likely is not going to work out nicely. But since we have like bases, 4 and 4, when we multiply like bases, we add the exponents. Apparently it's going to scroll. So we need to add 1/2 and negative 3/2, which is indeed negative 1. We could have done that in the calculator, let it do it for us, and it would tell us it's negative 1. Now, as we said already, powers of powers multiply. So negative 1 times negative 1/4 is 1/4. And that's it. I mean, we could simplify it further. It's not too big of a deal. As 2 to the 1/2. And they actually work out to be the same. 4 to the 1/4 is this here. 2 to the 1/2 is actually the exact same thing. And it's dealing with the fact that 2 squared, 4 is 2 squared, giving us 2/4. and 2/4 would reduce to 1/2. Any questions on this here? 17 through 20. And again, with these here, we could try plugging them into the calculator, see how it works. And especially with radicals. The 30xs will work out pretty nicely. I'm glad I saw that coming so I didn't just blow the mic out. But that's it. Now with any radical, the 30xs works very well, even if, just say, 74. 2 square root of 37. It simplifies radicals very nicely. If they get too big, it won't do it. But when I say too big, we're talking 3, 4-digit, well, most likely 4-digit numbers inside the radical that don't reduce. Then it's going to turn it into a decimal. So it has to be pretty big. Now, even with fifth roots, it normally doesn't do well with fifth roots. We could try plugging this in first, seeing if it gives us an answer that is an integer. We don't have a decimal. But if it does, well, 486 and 2 do divide evenly, where we don't have a fraction anymore, yes? 486 divided by 2 is 243. Now at this point here, we can see if we can take the fifth root of 243. Or if we did it by hand, we would go to a factor tree, which would be 3 and 81. 81 is 3 and 27. 27 is 3 and 9. 9 is 3 and 3. Well, how many 3's do we have? 5's. So 3 to the 5th. So we're taking the fifth root of 3 to the 5th, which is indeed 3. Which means, since there's no radicals, that we could have typed the original problem in, and it would have given us the answer. Questions on this here? Now the same thing is kind of true with this here. We could try typing this in first, seeing if it gives us an answer. Now since they're all cubed roots, we can write it as one big cubed root of 6 times 72 divided by 2. Now, at this point here, we could type everything that's inside the radical into the calculator. And again, we could try taking the cubed root of 216 in the calculator, and it gives us 6. If it didn't and gave us an ugly decimal, we would do the same factor tree, work it all the way down, just like we did with 243, and we would get 2 and 3, because it would work out that this is 2 cubed times 3 cubed, and the cubed root of it is 2 times 3, which is 6. Questions on this here? Now, if we do this with the last one, the fourth root of 8 times the fourth root of 8 does not give us a nice number. Part of the reason I know that is, well, I wrote the problem, so that helps. 8 is 2 to the third. So for both of them, we have 2 to the third and 2 to the third. Now, since they both have the fourth root, we can write it as one radical. And what's inside is 2 to the third times 2 to the third. To the 6. How many groups of 2 can we pull out? 1, because we can pull out 4 2's, so 1 comes out. Which is the same as the fourth root of 2 squared, which is 4. Incidentally, this is the same as 2 square roots of 2. Because if we think of this here, and this is actually the first time I actually went fully into this explanation. Because remember, the nth root of a to the x is equal to a to the x over n. Well, 2 over 4 reduces to 1/2, and 1/2 is just the square root of 2. So these are the same. Realistically, I would take either one. I'm not going to be a nitpick on making sure that you have them all in simplest radical form, or going all the way to where 4 through to 4 is not in complete reduced form. I'm not going to worry about that. Questions on this here? Or at least I'm not worried about it on a problem like this one here. We ready for the next one? The next set. What do we think the first step in solving 21 is? Because again, the main thing is the radical in the denominator. We can't have it there. Less than the review sheet. I don't know. I don't remember off the top of my head. Because to actually solve this by hand, we would multiply by the numbers that are in the denominator, but we would change the sign to negative. Now the calculator will do it for us, but if we multiply the numerator, we'd have 1 minus the square root of 3, which is very similar to what we have. The denominator would end up being 1 minus 3 if we multiplied it all the way out. I am skipping steps because I'm not doing the full multiplication, which would tell us that we have 1 minus the square root of 3 over negative 2. Now I'm going to take this negative out of the denominator and multiply it across the top, which is going to make the 1 negative and the square root positive, and the answer we got just flipped them. That's as simplified as it gets. I believe the 24, if we do plug it in, it should be 99 plus 11 square root of 6 over 75. I believe the answer key, I think, has minus. I'm not sure. You have, let's sneak a peek. Yeah, so it's supposed to be plus. Yep. So it's supposed to be plus instead of minus. Questions on 21 through 24. 25 through 30. Well, or as it's written, 25 through 29. But to do these here, to add or subtract, we need these to be the same. Now, 3 to the 1/3 is as simplified as it gets. However, the first one, I need to get rewritten as 3 to the 1/3, yes? So, because 8 times 3 is 24. I'm going to write this above it so we see what happens, because we are taking 8 out. Because our properties of exponents say that I could rewrite 24 to the 1/3 as 8 times 3, the product to the 1/3, which is the same as 8 to the 1/3 times 3 to the 1/3. And 1/3, or 8 to the 1/3, is 2 times 3 to the 1/3. So we get 5 times 2 outside. Well, 5 times 2 is 10 times 3 to the 1/3 minus 4 times 3 to the 1/3. Since the parentheses are the same, we can subtract the numbers in front, which gives us 6 times 3 to the 1/3. Questions on this here? Now, if the radicals or the parentheses or radicals had already been the same, we just add or subtract the numbers in front and we're done. Are we good with number 25? 26. Well, we need the radicals to be the same. Now, we can't reduce the cubed root of 2 any further than what it is, but we need the cubed root of 128 to be something times the cubed root of 2. Well, 2 times what is 128? 64. Now, luckily, or hopefully, we can take the cubed root of 64, which is 4. Now we can subtract them. 5 cubed roots of 2 minus 4 cubed roots of 2 is just cubed root of 2. That's as far as it goes. Any questions on this here? Well, what do you think we can do for 27? (27) square root of 6. We had what? Plus 7 square root of 150. Because again, the yellow calculator likes square roots. It works very well with square roots. Was it square root of 6? Because if it had been an other index besides 2, besides our square root, we would have had to work it out. But since it's square root, it works out nicely. Same thing's true with 28. 30 is a different question. Well, before we do anything with our 8th root, let's simplify our like terms. Because we have n to the 18th over n squared. So 18, we subtract them. 18 minus 2 is 16. Because when we divide like bases, we subtract the exponents. When we multiply like bases, we add them.
Kenzie boy, come to the office. Kenzie boy, come to the office.
And for p, we'd have 7 minus negative 1, which is the same as plus, giving us p to the 8th. How many groups of 8 n's can we take away from n to the 16th? So it'd be n squared. How many groups of p can we take out? Technically, we would need absolute.
Have your attention, please. It's now time to release the track. Kids, get ready to go to the track meet. It's now time to release the students to go to the track meet, the ones that are going. Thank you.
Now, as technically, we would need absolute values around the p because we took an even root, so it has to be positive. And since the exponent attached to p is odd, we would need it. But I'm going to take n squared times p as the correct answer. I'm not going to count off if you don't put the absolute values. Now, for the next one here, we can combine like terms. G to the 6th, that's the only variable g that we have. However, we have h over h to the 7th. So we can subtract our exponents. 6 or 7 minus 1 is 6. Since it's bigger on bottom, it stays on bottom, which would give us G over H. Any questions on this here? And again, like the last one with P, we would actually put absolute values around the whole thing because we took an even root and both the exponents are odd, but we don't have to. I'm not going to make us do that. Questions on any of this here? Find f plus g of x, f minus g of x, f times g of x, and f divided by g of x for each set of functions. We're not going to look at 31. We are going to look at 32. So the first one we're going to look at is f plus g, or f of x, f plus g of x, which is the same as f of x plus g of x. And f of x in our case is 4x to the 5/4 plus g of x is 2x to the 1/2. Yes? And since these are like terms, we can combine them, yes? Is x to the 5/4 the same as x to the 1/2? So if they're not like terms, no. I put that equals there, even though I knew that they wouldn't. Yeah, no, that is as simplified as it gets. Because they're not like terms, we can't add them. They're not the same. So that's as far as we can take it. Now we can do f minus g of x, which is the same as f of x minus g of x. Well, f of x in our case is 4x to the 5/4 minus 2x to the 1/2. Yes? And since these are like terms, we can subtract them, yes? They're still not, no. It's the same thing as the one above, just subtracted instead of added. Being added together. So that's as far as we can take it. Now we can move on to multiplication. F times g of x, which is the same as f of x times g of x, which is 4x to the 5/4 times 2x to the 1/2. And here we can actually take it a step further. Because with multiplication, we can do 4 times 2. 4 times 2 is 8. Now, when we multiply like bases, because both bases are indeed x, we add the exponents. So at this point here, to simplify it, we can't just leave it as x to the 5/4 plus 1/2. Right? Or we can add them together and get 7/4. Right, to be able to add them, we would need the bases to be the same so that we can add the numerators, or not the bases, we need the denominators to be the same so we can add the numerators, or we can let the calculator figure that out for us. And lastly, f divided by g of x is the same as f of x divided by g of x. Well, f of x is still 4x to the 5/4. G of x is still 2x to the 1/2. Now at this point here, we can divide, yes? 4 divided by 2 is 2. 5/4 minus 1/2. 3/4. If the numbers don't divide evenly, we'll leave it as a fraction, and then put x out to the side. Questions on these here? $33 and $34 will not be on the test. Because it's not that they're any harder than what we just did, they're just very time consuming. I'd rather focus the time on something else. Now we're going to look at 35. We can do 35 because all of these are about the same. We start from the inside and work our way out. So we'll plug x into g of x. And when we do that, we get negative 2x plus 5. And at this point here, we plug this in. Yes, exactly. We plug negative 2x plus 5 in for every x in f of x, which would be 7 times 2x plus 5 minus 2. Because we replace the x with negative 2x plus 5. At this point here, we distribute the 7. 7 times negative 2x is negative 14x. 7 times 5 is plus 35 minus 2 is negative 14x plus 33. So this here is f of g of x. Any questions on how we found f of g of x? Would we like to see 36, 37, or 38? We feel good? Yes. Because, I mean, they're all the same thing, just working from the inside out. Even f of x or g of x is just doing the same thing. We just take it. 37 and 38, we're just using the same function twice. If you do want to see one of those 4th hours, Algebra 2, I did do 37. So you can look at that one there if you want. 35 through 41. Is there one of these in particular y'all want to look at? 41. So I'm just rewriting those functions so I have them written there. But again, as I said with any of these, we're working from the inside out. So G, F, because the first one we're taking is G of 3, because we're taking it in place of X. So it'd be negative 2 times 3 plus 5. Now we could work this part out by hand, negative 2 times 3 plus 5. Or I could grab the calculator, say negative 2 times 3 plus 5 is negative 1. Any questions on what we just did? Yep, now we plug negative 1 into f of x. So we have g of f of g, because we're evaluating f of negative 1. So we'd say 7 times negative 1 plus, not plus, times negative 1 minus 2. Should be f of g, no, sorry, got them flipped. G of f of g, and again, we plug this in. 7 times negative 1 minus 2 is negative 9. Well, now we're doing what? G of negative 9. So we're just repeating the process. So negative 2 times negative 9 plus 5. And again, negative 2, parentheses, negative 9, plus 5 is 23. Now we're going to take f of 23. So 7 times 159. And last but not least, negative 2 times 159 plus 5. I believe should be negative 313. And that's it. So it's exactly like 39 and 40, except we do it several more times over. Now on a whole, is this problem complicated? It's just time consuming. You're just doing the same steps repeatedly. Yeah. But I would just take it one step at a time. This one here, especially with these multiple, I would avoid trying to actually do the calculations. Here, 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 any of these here out, because then you're having to rewrite this again and again and again. Go on and do those steps in the calculator so you get it stays a little more nice and neat. If this is a bit much writing it horizontally, write it vertically so you can make sure you are condensing it down correctly. Any other questions on 39, 40, or 41? Find the inverse. 42 or 43, which one do we want to look at? 43. Because these are going to be the same. The steps might be a little different when solving. But the first thing we do is replace, in this case, g of x. All the ones we had in class were f of x, but it's still the same. Replace g of x with y. Now we flip x and y. Now we get y by itself. We'll start off with addition or subtraction first. Adding 7, telling us 2y cubed is equal to. I would do the easier steps first. I would divide by 2. I try to get everything done with addition, subtraction, and then multiplication, division before I deal with exponents or radicals. I consider exponents and radicals to be the more challenging step than addition, subtraction, and multiplication, division. Now at this point here, we do have the y almost by itself. We just need to take the cube root. So these would cancel, telling us the cubed root of x plus 7 over 2. Now, yes, we need to write it, not y inverse, because I think, well, our original function was what? So we have g inverse of x is equal to the cubed root of x plus 7 over 2. If it had started out as f of x, we would say f inverse of x. So we just use g of x, g inverse, because we started out with g. Questions on these two here? I think we could finish 50 or 44 before the bell, because with solving, and we will pick this up on tomorrow, we get the radical by itself first. With 44, the radical is indeed by itself. So we can put both sides to the nth power. In this case, it is second. Now the square root of 2y squared is just 2y. 8 squared is 64. At this point here, we can divide both sides by 2. Now, if it does say to check your answer, check your answer. There are points attributed for checking your answer. And for this here, all we've got to do is say square root of 2 times 32 is equal to 8. 8's already simplified. Now I can grab a calculator, say second square root 2 times 32. Enter, we get 8. So 8 is indeed equal to 8. It works. We checked it. That is our answer. Now, I will say this here, and I've said it, I think, several times throughout the year, especially when we're solving. I do not put no solutions on the test. I just don't. There will be some that have an extraneous solution, so one of the 2 solutions doesn't work, but at least one will. Okay? I said this to 3rd hour because we did get this far, but I haven't said it yet to 4th hour. But if you do put a no solution on one of the problems, I will take full marks off. Because again, as I remind you, there is no solution on this test. So if you do put it, I'm going to take full points. So we'll pick this up tomorrow.